All right, so we left off yesterday looking at I. We did adding and subtracting, and we said I equals the square root of negative 1, and then we figured out that. What did we say I squared was?
One.
Negative 1.
Negative 1.
Yeah, negative 1.
Right? Because if you take I, which is the square root of negative 1, and you square it, squaring and square rooting cancel each other out, and you're left with what was underneath.
Yes.
So that means anytime that we do an arithmetic problem, I squared should never be left in the final answer. So if there is a multiple choice question, and it has I squared in the final answer, and you pick it, you are wrong. So I squared is never in the final answer. You always change I squared to negative 1. And usually once you change it to a negative 1, then you can combine it with something else. Okay.
I hope I don't get tricked with the test tomorrow.
Well, that's why I wrote that down. Okay, so let's look at multiplying first, and then we'll finish with
Isn't there another half of this lesson that we're doing?
Today.
this is the second half of the A4.
And then are we doing something after the second half?
Yeah, we're in about 25 minutes we'll do the last thing. Yeah.
Do we have to?
Yeah.
Is it required?
I plan on passing this test.
I mean, it's not required, but it's going to be on the test.
Well, think about it. If he's doing it halfway today, it's going to be that day.
So when you are multiplying two complex numbers, so let's say those are our two numbers, the A, the B, the C, and the D, those will all be numbers when you have an actual problem. Something kind of like that, 2 plus I times 1 minus I.
Skip over.
When you multiply these together, you do the distributive property. That's how you do it. Some people remember it as FOIL. Some people remember it as like the double distributive property. However you want to remember it, you multiply the first two together. Then you multiply the first one times the last one, the middle two together, and then the last two together. It's when you multiply the last two together, you're going to end up with an I times another I. That's where we're going to have to deal with the I squared. And it's important we know how to multiply because when you do division, you actually use part of multiplication to do it.
Wait, what?
When we get to division, you have to know how to multiply because part of the division process involves multiplying.
Is there something I don't know about multiplying?
Well, we're going to go through a problem right now and we'll see. So we're going to look at that one. 2 plus I times 1 minus I. Okay. First thing is, even if it didn't say the word multiply, you would need to know that that's a multiply problem. There's no plus sign between the parentheses. There's no minus sign. When you don't put something, it's multiplying. Okay. So I can scroll up a little bit. Does everybody have the top part?
2 times 1.
Yeah, but everyone has the top part.
Yeah.
Okay. Make that a little bigger. So yeah, we're going to start with 2 times 1. That's the first step. What's 2 times 1?
2.
2. Okay, second step. 2 times negative I. What's 2 times negative I?
Negative 2i.
Negative 2I.
Negative 2I.
A little bit like that.
I was trying to think.
So third step. What's 1 times I?
1i.
1I.
Or just I.
Or just I. And now the last step we're going to do in 2 parts.
I times negative I.
So first of all, it's a positive times a negative.
So it's going
Does
to
it cancel out?
So a positive times a negative gives you a negative. And what's an I times an I?
be 2I. I squared. Capital I.
I squared.
But it's going to be positive 1.
So now we still have some like terms we have to combine. For now, just leave the 2 in front. What's negative 2i plus 1i.
Negative I.
Just I.
Just
Negative I.
like negative 2 plus
Oh,
1.
Negative 1i, okay. So
Negative 1i.
I got you.
And now this part at the end, you still have that minus for
But we
now.
need to get rid of the I squared though, can't that not be there?
What is
Negative 1.
I squared is negative 1. Now, once you change that to negative 1, you can combine it with the other number that doesn't have an I. What's 2 minus 1?
It's 1.
So that gives you 1. That takes care of that and that. And,
Negative
whoops,
I.
hold
1
on.
minus I.
No, it's still negative
You
2.
did it wrong.
You got add it. You got ahead of yourself.
Yeah, I got ahead of myself. When you subtract the negative, what
Oh,
happens?
you gotta plus it.
Right.
Makes it plus side.
So it's gonna be 2.
It's gonna be 3.
Okay. A minus becomes a
Positive.
positive. Now we can do it. What's 2 plus 1?
3.
3. And what else is left?
Negative I.
Negative I.
Yes.
And that's the final answer.
That's a lovely answer.
Any question on? We'll do another one. But any question on the first one?
I think we got this down.
Need some more practice.
Okay, well.
I think we can do it by ourselves.
Yeah, we can do it by ourselves.
We can do it by ourselves.
Yeah, we can definitely do that one by ourselves.
All right. Why don't you we'll try that one?
If I didn't do it on my own.
Okay. 8 plus I times 3 plus I. When you're done, your final answer should look just like this. It's either going to be a plus or a minus. I'm not sure. We'll figure out which one. But there'll be a number in that box and a number in that box. And then an I next to the box at the end.
I'm white, but I'm not that white.
Okay, what's the first thing you multiply?
8 times 3.
Okay.
Equals 24.
Okay, so 8 times 3. Next one.
8 times I.
And how much is that?
8I.
So 8i, and what's 3 times I?
3I.
So what's 8i and 3i?
11I.
11i. And then a positive times a positive is a,
Is a positive I
So
squared.
it's gonna be I squared, so it's gonna be
But it's gonna be
minus
negative
1.
1.
so that I squared is going to turn into negative 1.
So you
Which
can
will
get
And then
rid
you
of the
subtract that from
23
24 and you get
plus
23.
one.
And
And
then,
then
yeah.
you always
so good.
you always can combine the first one and the last one together.
Hey, you were good, dude.
In your,
Is there fractions in
Please don't add fractions.
Yes.
yeah.
Please don't add
Yes.
He does that, he is.
fractions. I know you did.
I don't know how to do fractions. Can we do
Okay.
one with fractions?
Yep, we're going to.
No.
Okay. So any question on the multiplier?
No.
Okay, so now we're going to look at division.
Yay.
So when we do division, that's when fractions are going to come up.
What's the Z?
So to do division, the first thing I have to explain is what is called a conjugate.
Oh my.
So Z just represents a complex number. A lot of times if you don't know a complex number, we just say, well, there's a complex number, we call it Z.
How would you not know?
Like if you were solving an equation and you didn't know the answer, and it was a complex answer, they might say solve the equation for Z. They just call Z your complex number.
So Z is the answer.
Yeah, so Z is just it represents any complex number.
Why is there a line on top?
So when you put a line on top of the Z, that means conjugate.
What the hell does that mean?
Means conjugate of Z.
What's a conjugate?
So the conjugate
No.
of a complex number is when you change the sign of what's in the middle. So if it was like 3 plus 2i, it becomes 3 minus 2i.
Is the Z supposed to have the line over it?
Yes.
Oh my god.
Yes.
Well,
That's,
I just noticed it didn't have it up there.
This is a
Yeah.
Greek letter.
so Z, no, English letter.
Oh.
So Z just stands for a complex number. Z with a bar on it stands for the conjugate of the complex number.
What is a conjugate?
No, I don't know either.
I've been writing this down. I don't understand what I'm missing.
So the conjugate is when you change the sign of what's in the middle. If it was a positive, you make it a negative.
But why wouldn't you just change the sign, not put a line over it?
Because we don't question
Well,
that.
that's the symbol. So
I don't
like,
understand things.
if I say to
I don't
find,
understand how it relates to the polar coordinates.
if I say to find
We're not
that,
on polar coordinates anymore.
you have to know what that means.
It
Like I might-
means it's a plus or
It
minus?
means the conjugate of Z.
Yeah.
But so is it a minus or so?
Oh my
You're not let me talk.
Not
He's getting to the point.
Well, if he's explaining it, I don't understand the explanation.
I haven't scrolled down yet to show
Oh, I
it
thought
to
you
you.
were done.
Mr.
Oh
Hager,
my God.
would you rather teach us or preschoolers?
I think we're
we
just
are
as
pretty
bad.
I
So,
don't understand.
At least preschoolers have an excuse.
so Z represents a complex number. Let's call it 5 plus I. Okay, it just represents a complex number. Z, we already talked about what I was yesterday. So Z with a bar on top of it represents the conjugate of your number. When we do division, you are going to have to know what the conjugate is. Okay? If you can't figure out the conjugate, you're not going to be able to do the next step, which is division. The conjugate of a complex number is when you change the sign of the imaginary part. So the imaginary part is like, in this case, it's a positive 2i. If you change it to a negative 2i, that's called the conjugate.
So it's a plus or a minus sign, or a division or multiplication sign?
Could be a plus, it could be a minus, depends on the original problem.
So say I changed the thing to division, the conjugate would be a division sign?
So,
Under the law is the-
To find the conjugate, you change the sign of the imaginary part. You have two options for that sign. It's either a plus sign or it's a minus sign. It's not both. We just talked about that a second ago. I think Wyatt asked me. It's either plus or it's minus.
We just swap it.
You swap it.
And the equation's imaginary.
So
No, the I is.
if we had 3 plus 4i, what would be the conjugate of 3 plus 4i?
3 minus 4i.
Right. That's the conjugate.
Drop out of school.
Okay. That's not division. That's just how you find the conjugate. We're
So
gonna-
the
we're gonna-
conjugate has been found.
Yes.
So it's like a reciprocal,
Well, you're not flipping, you're changing the sign.
flipping the sign.
Yeah, usually we think of reciprocal as doing something like this.
I'm doing the opposite.
You
Instead
take
of adding,
the,
I'm
yeah,
subtracting.
you make it the opposite.
Mr. Hager, I admire your patience.
Yeah.
He's
I
about
try.
to smash.
It's like a swing and a miss, dude. It doesn't make any sense.
How about negative 8
Would it
minus
be plus?
2i?
Negative 8 plus 2i.
The conjugate is negative 8 plus 2i. And again, if you're not sure why we're changing that sign, you're going to see in a second. But we have to know how to do it first.
So
How about 5i?
negative 5i.
Right. Okay, so if that one you're not confused because there's no real part, think of it like that. It's 0 plus 5i. The conjugate is when you change the sign, so it's 0 minus 5i.
So the conjugate is the result of you changing it, or flipping it.
Flipping the sign of just the imaginary part. You don't do anything to the number in the front.
Yeah.
So the 3 stays the
middle
same.
sign.
Yeah, what's in the middle? How about 3?
Negative 3. It's just 3.
It's
Three.
not imaginary.
What's-
Because there's no I.
What's the imaginary part here?
0.
Think of it as 3 plus 0i.
So 3 minus 0?
The conjugate is 3 minus 0i.
Okay, so how did you know? So
Plus 0 minus 0, same thing.
I'm gonna drop out.
Okay. Any question on how you find the conjugate?
No.
I think there's a couple
the
of
other
guys
question-
there.
Yeah, there's a.
I think they all have questions back there.
Question on how you get the conjugate?
Oh, I'm completely lost. I picked it up.
Just drop out, buddy.
Yeah, I think.
Have fun.
So the conjugate is when you just take this symbol and change it to its opposite.
So conjugate's a process, not a number. Like
Yeah, it's the process of changing that symbol from a negative to a positive, or from a positive to a negative.
But you only change it if there's an I.
You change the one that's in front of the I, yes. You don't change the 3. That's not the I. Yeah.
Sounds
You change the number, like if you had 8 minus 4i, what's the conjugate of that?
8 plus 4i.
Yeah,
Mr. Hager, I'm gonna start a fan club with you.
you just change the sign
It's
of what's
either
in
a
the
number
middle.
or another track.
What?
It's either a number or another number.
that's not what he's talking about.
Yeah, he's talking about numbers, so.
Other question on that?
I think
Yeah.
there's lots of questions inside this room.
Have you ever-
So now,
That's not.
what we're going to use the conjugate for is division. When you have a division problem like that, the problem with it is you can't leave I in the bottom.
Oh, so you have to bring it to the top. top.
Well, it's okay in the top, yep. So we need a way to get rid of it in the bottom.
I can't read the bottom.
How, same reason we don't leave like a square root in the bottom. It's not considered simplified. So like the directions would say to divide, do not leave I in the bottom. So you can have it in the top. The way you get rid of it in the bottom is to use
You flip the side.
the conjugate. In order to divide two complex numbers, you're going to take the top and the bottom, and you're going to multiply by the conjugate. Multiplying by the conjugate will get rid of all the i's in the bottom. And we'll go through an example.
You have to.
So you have to multiply when you're doing a division problem. You'll have something in the top, you'll have something in the bottom. You're going to multiply the top and the bottom by the conjugate.
Wait, where's the fraction? How do you get a fraction?
I'm going to give you one.
What? I don't.
He's getting to the
Just,
fraction.
he's gonna give it to you and then you're gonna understand it.
So you're on the test. You're just gonna give us a fraction, and we have to do this.
Yep.
Because
I'm
okay.
going to say just like that on the test. I'm going to say divide, and I'll give you a problem like that.
Okay, 1 second.
Okay, so the directions say to multiply the top and the bottom by the conjugate. So what I usually do is put it in parentheses. Put everything in parentheses.
Denominator is the bottom, right?
Yes. So what is the conjugate of the bottom?
3 plus, minus 4i.
3 minus 4i. So you're going to multiply the top and the bottom by 3 minus 4i.
Wait, so will it always be a 1? I thought we were dividing two complex numbers.
That's a complex number.
1?
Mhm.
How?
It's a complex number, it just doesn't have an imaginary part.
I thought to be a complex number it needed an imaginary.
No, everything's a complex number.
An imaginary is an imaginary number.
With an eye.
I get that.
Yeah, you do not need to have an I to be complex. You need to have an I to be imaginary. Yeah. Okay, the next division one we do, it's gonna have a number in the top that
Okay,
also
that's
has an
like
I.
a complex number. To me.
So, yeah, every number you've ever studied is complex. Just sometimes it's complex with an imaginary part of 0. If the imaginary part is 0, I'm not gonna write it. But it's still complex.
I'd rather you write it.
Mr. Hager, can you please tell me
good
I'm
idea.
gonna wake up in 10 minutes?
So, in the top, this is the easier one. We have to just do a single distributive property.
Oh, 3 to 1 and then 3 to 4. But
Multiply
you
the
can't-
1 to everything.
Can't you not?
What's 1 times
3.
3? 3.
Minus 4i.
And 1 times negative 4i?
Negative.
So even though they're one has an I and one doesn't, you can still multiply them. Like they don't need to be like
There was like a
terms?
multiplication.
No, when you multiply, you don't do it like terms.
Okay.
Nope, that's only adding and subtracting.
I didn't know that.
And because it's a 1, in this case, it doesn't actually change anything.
Okay, but if it was a 2, it'd be negative 8.
If it was a 2, it would be 2 times 3 is 6.
Yeah.
2 times negative 4, yeah, I mean,
Okay,
yeah,
I get it.
negative 8. Okay, now let's do out the bottom.
So now we need to boil
Now we need to boil.
it. 3 times 3.
3 times 3 is how much?
9.
So we get 9. What's 3 times negative 4i?
Negative 12i.
Negative 12i. And what's 3 times 4i?
I think it's
12i.
12i.
Not gonna lie.
And now the last part, a positive times a negative is what?
Negative 16i.
Negative. And what's 4i times 4i?
Negative 16i squared.
I squared. Okay, can we do anything with the top?
Yes. Combine the. Wait.
No, you can simplify the 9 and the 3 though.
Yeah, well, how about the top though?
No,
No.
nothing.
No. So the top stays the same. And what's going to happen in the bottom?
You can combine. One I is going to disappear.
What's going to disappear?
12i.
12i and,
The negative 12i.
okay, so when you multiply conjugates, you're always going to get the 2 in the middle that disappear. Because one's going to be a positive, one's going to be a negative, and they're going to be the same number.
Okay.
So plus 12i minus
So
12i.
then you're just left with 9 minus 16i squared.
So we have 9 minus 16, but what's I squared?
Negative 1.
So
would
it's
it be
really 16 times negative 1.
So it needs to be 9 plus 16.
So in the bottom, a negative, and that's a negative. What's a negative 16 times negative 1?
A positive 16.
That's a positive 16. So notice what happened. All the i's are gone from the bottom. And every time you do division with the conjugate, that will always happen. What do you get when you combine like terms in the bottom?
25.
25. Now, we can't leave the final answer like that.
Wait, what happens to the
Do
next
you have to
one?
times it by 25?
The final answer has to be written like this.
Would you?
Real part and imaginary part is two separate. You can't have one big fraction.
Would you times it by 25 over 1?
Nope, you don't have to times it. So when you want to write it separately, you take each part and put them over the 25 separate.
Oh.
So it's 3 over 25. Copy down the minus, and then 4 over 25. That's how you would write it in standard form. So once you get to this step, just separate each number over 25. And if this reduced, I would. Like, let's say I had 5 over 25.
Why do you add the I to the 4?
The I was always with the 4.
So why is it not with the 4 now?
It's
It still is.
still with it.
So can I write 4i there instead of 4 then I?
You could. It's kind of like when you have y equals mx plus b. If I'm going to write a slope that's a fraction, I usually do it like that,
Instead of what?
instead of doing something like this. Whether you put the x in the top with it or out in front,
So it could go with it, you won't like
Yes.
give me a 0?
yeah, you could do it with it. If it's multiple choice though, you're going to see it in front.
Okay.
Usually when you have a fraction in math, the letter goes next to the fraction.
Okay.
They usually don't put it like that, even though it is the same thing.
But those letters don't mean anything. The I means something. Right?
The x means something.
Well, it's
The
a
X
this.
doesn't have a value, but the I has a value.
X has a value.
What
Yeah,
is
well-
X's value?
In an equation.
Well, it's a variable, so it
It
still
could be any
means something.
value.
Yeah, it could be any value.
But I has a set value.
Right. Yeah. So they are different, but in the sense of where you put it, usually in math they put something that looks like a letter next to a fraction. But yes, I agree. The I and the x are a little bit different. Yeah. Yep. All right. Let's try one more of those. Okay. So once you multiply conjugates a lot, you start to get pretty quick with them.
Wait,
Like I can tell you the bottom right now, it's going to come out to 169.
Wow.
Let's do it out and then watch what happens. The top, I don't know what that's going to come out to. That's a little more complicated. What are we going to multiply the top and the bottom by?
5 plus 12.
5 plus 12i. Okay. So let's do the bottom first. What's the first thing you multiply?
5.
5.
5 times 5, and that's how much?
25.
Okay, keep in mind that number I said, 169. What's 5 times 12i?
60i.
60i. What's 5 times negative 12i?
Negative 60i.
So that's gone. 60i, negative 60i. So we don't need to write that. What's a negative times positive?
Negative.
Negative. And what's 12i times 12i?
144.
144 I squared.
And then, but I squared would be negative 1.
Right. And then you're going to end up with 25
Plus 144.
plus 144.
Would that equal 169?
Yeah. Yep. Because you're going to change that to negative 1, and it's going to make it a plus. Okay. So the bottom you can do kind of fast once you get used to doing it. Okay, I'll finish and add those up in a second. Let's do the top. What's 1 times 5? So you get 5. What's 1 times 12i?
12i.
So 12i and 5 times 4i.
20i.
20i. What's 20i and 12i? 32i. And the last part, positive times positive.
48i squared.
That's a positive 48i squared. Okay, so that's the top. Now, 48i squared is really what number?
Negative 48.
That's really 48 times negative 1. So we get that. And now if we add what's in the bottom, 25 and 144, we just said 169. What's 5 minus 48? Or think of 48 minus 5 and make it
Negative 42.
negative 40,
3.
negative 43 plus 32i. And now my last step is just to separate that into a real and an imaginary. What's going to be the real part?
Negative 43 over 169.
Negative 43 over 169. Perfect.
Plus 32 over 169.
32 over 169. And again, if you put the I next to the 32, it's okay. But normally, they put it next to the fraction. Okay. Any question on that? So that's the multiplication and division. So you'll have one add, subtract, multiply, and divide on the test. But I'll put a list of test topics up in just a little bit. Okay, so the last thing, the complex plane. What the complex plane allows us to do is graph a complex number. If you can graph 2, 3, then you can graph 2 plus 3i. It's the same idea.
Oh, I think I get it.
On the complex plane, they don't call the axes x and y. They call them real and imaginary.
You go over by
The real axis goes left and right, and the imaginary axis is up and down. So to graph the point 2 plus 3i, what's the real part?
2.
2. And what's the imaginary part?
3.
3. Positive 2, positive 3. Right 2, up 3. So to graph 2 plus 3i, that's where it would be. You cannot switch the axes. If you accidentally put like the imaginary one going horizontal, that's like switching x and y. You can't do that. Real is horizontal, imaginary is vertical. What's the real part of that number?
4.
And the imaginary?
8. Negative 8.
Negative 8. So we're going to go right 4, and then which way?
Down.
Down how many?
8.
I think it's right there. Right 4, down 8. What's important is the quadrant we end up in, because the quadrant is going to tell us something for the last thing we do.
Just like how what quadrant it was told us what we were doing yesterday.
Yes. Yep. So when we had to know the quadrant, it's exactly the same thing, like inverse tangent y over x. It's going to be the exact same thing with this. Yep. What about negative 8?
It would just be at -8.
Which way?
To the left.
Left. So that's negative 8. Again, that is a complex number. Even though there's no imaginary part, everything is a complex number.
Then I think we should only work with whole numbers.
How about 5i?
5 up.
5 up. Okay, so there will be a couple questions on the test where you'll have a grid. You just
And then I'll
click
do that.
and you put your point where you need to put it.
But you're not in the circle. I mean, like, how many questions that are not going to be graphs? Because, like, we did a lot of circle graphing, too.
There'll be 2 of these and 2 of those.
So,
It's probably about 4.
like, 4 out of 14, maybe?
No,
Yeah,
we
maybe
said
6,
100 and something
16,
earlier.
No, he said 500.
All right, so the last thing we're going to do is making a connection between what we did on Monday, which was polar, and what we've done the past couple days, which is complex numbers.
Maybe not.
Okay, when we write, now we have to. So when you write a number in polar, what are the two letters that you have?
The radius and the angle.
Yep. And when we write a complex number in polar, it's going to be the same thing. You're going to have a radius and you're going to have an angle. So we learned how to take regular numbers and write them in polar. Now I'm going to show you how to do a complex number in polar. So again, I'm using the letter Z. It just represents a generic complex number. Now, when we write a complex number, I know that I normally use the letters A and B. I think this is how I was doing it yesterday. I'm going to switch to using X and Y because now that we're graphing, I think if I use X, you'll be more likely to remember that the first part is horizontal. And if I use Y here, you'll probably remember that Y is vertical. Okay? The letters you use are not overly important, but X is your real part, which is left and right. Y is your vertical, which is up and down.
Why is the I before the Y?
So we normally put the I after the letter. You can put it after the letter. What I'm trying to do is match what your book is doing. So your book has a formula they're going to come up with in a minute, and they put the I in front. So you could put the I after it, though. It would be the same thing. But our book doesn't. Just how they do it. Okay. That format is called rectangular form. So 3 plus 6i. That means right 3, up 6, if you were going to graph it. Rectangular form is when you move left and right, and then you move up and down. When you're in polar form, you don't use X and Y. These two letters are going to disappear. What are the two letters we use again?
A, B.
R and theta.
R and theta. So in polar, you use an R and a theta.
Wait, so the Y or the I doesn't do anything when you're graphing it rectangular?
So the I tells you that that's the up and the down, because the I is your imaginary axis.
Okay.
Yeah. On Monday, we had a formula for X. Does anybody remember when we were converting between polar and rectangular, what was our formula for X?
R sine theta.
R
Cosine.
cosine
Theta.
theta. And what was our formula for Y?
R sine theta.
So the nice part about this section we're doing, every formula we need, we already learned on Monday. There's no new formulas to figure out. Any question on those two? That's from Monday. Now, take that and fill it in right there. Take that and fill that in right there. If you plug in those two things, R cosine theta for X, R sine theta for Y, that is how you write a complex number in trig form. Plug those two things in. So you would have, I'll just write this again. So X and Y. Fill in this.
Wait, I thought Y you had to add 182.
Not to
That's
be.
a
No.
different thing.
No, that's another thing. That's not with sine and cosine.
Ah.
So fill in R cosine theta for X and fill in R sine theta for Y. So if I fill those in, what would it look like?
R cosine theta plus I R cosine sine theta.
Plus I, we just copy that down, and now fill in the Y, R sine theta. Now, in front of the trig function, what letter do both of those have in common?
R.
R. When two terms have the same letter, you can put it in front of them both. That way you don't have to write it twice. So we can put an R in front. And if we take the R out of the first one, because now it's in the front, what's left?
Cosine theta.
Cosine theta. And if we take R out of the second one, what's left?
Sine theta. I sine theta.
I sine theta.
So it doesn't
Yep.
matter that the I is before the R?
No, that's how the book writes it.
Okay.
And that is how you write a complex number in polar. What I just wrote up above, I just copied it down again.
How would you know what, put for your R's and theta?
Okay, so how do we know what to put for r and theta? How did we figure out r yesterday?
That was the hypotenuse, yeah.
That was the hypotenuse. How did we find that?
That's the a squared plus b squared.
Yep, we used Pythagorean theorem. Okay, so if you look back at your formula from yesterday, you had r squared equals x squared plus y squared. So we can figure out r. And how did we figure out theta?
We decided what quadrant it was in and then used the formula for it.
Yep, we had to decide what quadrant it was in, and what was the formula we used? What was the formula for quadrants 1 and 4?
Inverse tan y over x.
And it's the same formula today. Yep, inverse tangent y over x. And what if you're in quadrants 2 or 3?
Wait, what is this
180.
formula then?
180 or pi. You had to
180 or pi
You had to add.
plus the inverse tangent of y over x. So the formulas you use to find theta and to find r are the same formulas we used yesterday.
So what does this formula do if we're using the other two formulas?
What does this whole thing in the box do?
Yeah.
That we would have really seen tomorrow, but we don't have tomorrow, so we never
So we're
get
not using it?
we never get to the final thing you can do with it. What
So why do we know,
So what we could end up doing with it is making this whole process a lot easier. That's the next step.
so I can disregard this formula?
I'm going to ask you something about it still, but I'm not going to ask you to do division with it.
So we're not actually applying it to anything?
Not division, but you are applying it to something.
Have you gone over that yet?
Yeah. Nope.
Are you about to?
Yeah.
Okay.
What that formula really does is it makes this entire process go away.
Why don't we start with
We couldn't start with it because we haven't learned it yet.
why don't we learn it first?
Because it's harder to learn than the other thing. Because there's multiple steps to it. Because you have to know how to graph a number in complex. You have to know how to convert the x and the y into our cosine theta and our sine theta. There's just more stuff that goes into knowing
Did
it.
we talk about how to convert it into?
Yes, we did that on Monday.
Okay.
So
Oh, wait.
once you know how to use this format, it makes division and multiplication a lot easier.
So-
You don't have to do the foiling, you don't have to do the conjugate, but you have to understand all of this before you can do
Okay,
that.
so the x plus is, I don't understand.
So that's a complex number in rectangular,
Yeah, which is
Like-
what we've been dealing with,
like
right?
that. Yep.
What is that?
So that's a complex number in rectangular.
Okay, so then you would do the square root of 3 to, I don't understand.
So that's rectangular,
Yes,
right? We're gonna convert that to polar.
yes.
So when we're done, we're going to have something that looks like what's in that box. Our final answer is
I
going to
thought we were
look...
using the r cosine theta to find x.
That's what that is.
That's what that is. That's your r cosine theta, that's your x right there.
Look.
And this is...
I thought you said we were
That's your
using
y.
these two and not this one.
So when we're done, you're going to have a final answer that looks something like this. Just making these numbers up.
Okay, I just don't know where you put the numbers in, I guess, is what I'm confused about.
So that is an example of a final answer.
Oh, so wait, can you put on again?
You don't do anything else with them. You don't take the cosine of 10, you don't take the sine of 10, you don't distribute the 5. That is a final answer when you are writing a complex number in polar.
Why
Can
wouldn't
you
you do
scroll
that?
down for a second?
And we're going to do that right now. Again,
So-
5 and the 10, I just made those numbers
So
up.
negative 1i would be the theta.
So the first thing we have to do is graph.
Wait. What? I thought we were using these formulas.
We're going to in a minute, but we have to graph it first. Okay. What quadrant is that point in when you graph it?
The second one.
Up here?
4? Yeah. No. The fourth one.
Fourth one, right? Positive, negative, somewhere over there. So when you graph that number on the complex plane, it would be right and down. So we got it graphed. Next thing we have to do is figure out that distance right there. Whatever that is, that number is going to get filled in.
Wait, but
Right
I thought
there.
you said the R was the X.
So R is the distance from the pole to the point. R stands for radius.
Did we go over this today?
No, this was Monday and Tuesday when we talked about what R is.
I thought we didn't do complex numbers yesterday.
So what we're using the same formulas from Monday and Tuesday to do what we're doing today.
Okay.
It's
But
the same
Didn't
formulas.
you just say that X goes in the R spot?
Well, let's just start with finding R. Okay, so we've graphed this point. You go right and you go down. Now think of it as a triangle. How long is this side?
Oh,
It's given,
it's square root of 3,
square root of 3. And how long is this side?
negative 1i.
So how long is it though?
1i. 1.
1, yeah. Just down 1.
Why not I?
Because when you're measuring the length of something, it's just a number that's real.
But doesn't the I have value?
Well, the I tells us that I went down vertically. Yeah. All that does is the I tells me it's down and up instead of left and right.
Oh.
But down is it's still just 1 unit down. How would you find R, knowing that side?
Taking this squaring, or squaring square root of 3,
Square that,
and then square 1,
square that,
and then add them together,
add them up.
and then
One more
get
thing.
R.
No, not yet.
Square R.
Square
Wait. what?
root.
Oh, I didn't remember that.
Okay, so you square each leg, add them up, and take the square root. This is just the what? Really, what theorem? Yeah.
You have to square everything in Pythagorean?
Mhm. Yeah, you always have to square things in Pythagorean theorem.
No, you just square the answer.
You have to square each leg, add them up, and then take the square root.
Of everything, not just the answer?
You have to take the square root of the whole thing. This plus this.
That is A squared plus B squared.
That is, because if R was squared, then
Yeah.
you wouldn't use that squared thing.
C squared equals A squared plus B squared.
So you could have just add A squared and B squared together and then square root C?
So add A squared and B squared together, and then take the square root.
Oh, you just did it differently than I do it.
Yeah, so just square that, add them up, and take the square root. So what's square root of 3 squared?
3.
3. And what's 1 squared?
1.
1. And square root of 3 plus 1 is
2.
2. So when I write my final answer in a minute, my radius is going to be 2. I'm just going to put that off to the side. So radius is 2. Now, what's the other thing that I need?
The theta.
I need the theta. We're going to find the theta the same way we found it yesterday. What quadrant am I in?
4th.
4th quadrant. What's the formula to find theta in that quadrant?
Inverse tan y over x.
Inverse tangent of, that's x. First number is x, the second number is y.
Square root of 3 over negative 1i.
It's the square root.
So what's y in this case? That goes in the top.
1.
1.
Negative 1. Right, because it has a negative with it.
And
Not
then
the
3.
I.
No, not the
just
I.
tells you
The
whether
I is just there to tell me that that's just vertical.
Oh.
Remember, the actual imaginary part is the number in front of the I, and that's the real part.
Oh.
So the I is just there to tell you what's in front of it is imaginary. So that's in the top, and what's in the bottom?
Square root of 3.
Square root of 3.
Square root of 3. So we need the inverse tangent of negative 1 over root 3. Okay, when you do inverse tangent with a root 3, it's going to come out nice. So it doesn't look like it's a nice number, but it will be. So second inverse tangent, square root of 3. So that's negative 30 degrees. Now, I plug those two things in and then stop, and that's my final answer. So it's going to be r cosine theta plus I sine theta. So for our problem, r
2
cosine
30, negative 30
theta,
plus I sine negative 30 degrees.
and that is the final answer. If they didn't want it with a negative angle, we can get rid of that the same way we do with real numbers. Bless you. What can you add to that?
Inverse.
You could add 360. So instead of doing negative 30, that's the same as going how much the other way?
330.
330. This is exact same answer.
Is this the last thing we're doing?
Yeah.
Wait, so do we have to switch it to that way?
It depends if they say write your answer with a positive
Can you not
angle.
write that on the test?
Well, if it's if it's a multiple choice, then you may have to figure out which one is right. So you have to know to add 360 to make it positive.
I see.
These would not both be listed as multiple choice answers because they're both right. Right? If it was only, one of them would be listed.
So on the test, are you always going to stick to degrees or always radians, or are you going to have a mix?
I think there's some degrees and some radians on the
Okay.
test. Yeah.
Can you explain why negative times negative equals positive?
But let's do another one of the things that's on the test, and then yes, remind me.
Okay.
We forgot yesterday. Yeah. Let's make up another one. How about? Let's do.
Thank you.
Let's do negative 2 plus 3i. Same directions, right in polar. We'll just call it example 2b. Okay. So what are the two things we have to figure out?
The theta, and the angle, and the radius.
Theta and the radius. Converting this to polar is no different than converting that to polar. That's what we did on Monday and Tuesday. The only thing that's different is how you write the final answer. Okay.
So wouldn't it be in quadrant 2?
So that would be
Because you go over 2 and up 3.
left 2, up 3.
So don't we have to add 180?
So we do have to add 180. What's my formula to find the angle?
180 plus the inverse of tangent y over x.
Inverse tangent. And what's y in this
3.
case? Y is 3.
And x is negative 2.
X is negative 2. Okay, so type that in, and we'll have our angle, which is the distance or the rotation from there to there. That's your angle.
I thought we had to use Pythagorean theorem.
We do. We haven't done that yet.
That's for the other number.
We just did it for this
So 180 plus inverse tangent of 3 over negative 2. That's 123.69 degrees. That's your angle. Yeah, let me do 3 decimal places. 120. Oh, okay, it's 123.69. Next one is a 0. Okay, so let's keep that in mind. And now we still have to do Pythagorean theorem to get r.
So it'd be 3 squared plus 2 squared, square root of.
Yeah, so square the 3, square the 2, that's 9, that's 4. And what do you get when you add them? 13,
Square root.
and then take the square root. So that is your radius. So that's finding the hypotenuse of that triangle. Now, when you write your final answer, you're going to write it just like we did up above. R cosine theta plus I sine theta, and then stop. So R, and then what comes next?
Cosine.
Cosine of
123.69.
169 plus
I.
I.
Sine 123.69.
69. And that is your final answer. Now, if you wanted to make sure you did it right, then you could take that and multiply it by the cosine and see what happens.
Oh, you should get.
And I should get back what I started with. So if I do square root of 13, second square root of 13 times the cosine of 123.69.
Can you just do the second answer because it's already a bit?
And
then be more exact.
Yes. I can do second answer, and I get negative 2. That's what I started with. Now I can't do answer because I just messed it up. But if I do square root of 13, square root of 13 times the sine of 123.69, what should I get when I do that? Yeah, I should get about 3i. I get 3.00000 because of rounding. But if you do that out, you change it back to what you started with. That wasn't the goal. You don't want to change it back. I wanted to just check it. Okay. What's in the red box is the final answer.
Sounds good.
Okay. Any question on that one? So that's converting a complex number to polar. And the real advantage, let's say I had two complex numbers like this. And I had, I don't know, 5 cosine 4 degrees. 4 degrees. If I wanted to multiply those two complex numbers together and get the answer, instead of having to FOIL it all out and do the conjugate, when I multiply these together, I can tell you the answer would be 15 cosine 14 plus I sine 14. That's the final answer when you multiply those two together. And I didn't have to do any...
Are we gonna have to multiply those things together?
No, just you asked me where this is really useful.
Oh.
And if I wanted to divide them, the way that we learned, you have to find the conjugate, you got to FOIL it, change the I squared to -1, combine like terms. I don't have to do any of that with this. If I was going to divide these two numbers, the answer would be 3/5 cosine 6, I sine 6. Done the whole problem. That's how quick you can divide two complex numbers if you know how to write them in polar, which now we do. But that would be the next step, which we're not going to do. We're not going to get to that. Okay. So the advantage of this is it makes multiplication and division extremely fast, much faster than the way we learned before. But we didn't know this before, which is why we didn't do it. Okay. Any question on that? And I'm not sure if you can tell what I did, but you know,
You just said.
I added 10 and 4 when I multiplied, and I subtracted 10 and 4 when I divided. The calculation becomes very, very simple. Okay. None of that to do division. You don't need any of it. All right. So the first page, that's on multiplying and dividing complex numbers. And the second page, that is on writing complex numbers in polar.
Mr. Hager, if we all pass this test, can I get a high five?
You get a high five?
Yeah.
If you want a high five, sure.
Can you do the negative number thing?
Yes.